So DHCP, dynamically asked control protocol, we have seen that. What it requires? It requires a server, either the NT or Windows NT MS server. Static IPs, default gateways, it need to have. When we say the default gateway, this is the gateway which is residing at the edge of the network. Suppose you have one office. Suppose example South Central Railway. It has got two different divisions, 4 divisions. 4 divisions will have different router to serve within that network. And when it comes, it goes to the external side. You have a default at zonal side at Secunderabad, zonal side. So the first which is entering to the external world, that is called default gateway, which is connected internally to route it, that is called the local routers. So default gateway is the router which is connecting to the external world, that which resides at the edge of that network or the border of that network. The domain name service, this is the service where we are, this is a service where we regularly use it, domain name service. The network understands only IP address. It doesn't understand the names. Suppose you have the yahoo.com. Yahoo.com may be having 168.22.16.6. But for human being, it is difficult for us to remember that. We remember only yahoo.com. Suppose you want to do traceroute yahoo.com. You can do traceroute yahoo.com. The DNS server and the system come into place will translate that yahoo.com into his IP address and sends on to the network to get the response from the yahoo.com. So this is the DNS server, how it works. So in the internet, we have IPv4, we have almost 4 billion IP addresses. It is difficult for us to remember any IP and all. So that's why DNS helps us to translate between an IP address to the name of particular destination. Example here, instead of remembering 205.216.138.22 is an IP address, all we remember the domain name is ds.co.in. If you want to trace route ds.co.in, it will trace route and translates on the network with the IP address of 205.216.138.22. And we have a separate, how we acquire the domain names. In India, it is the NCST. It provides the domain names. You might have seen in your mail ID, you all got for your e-office gov.in. Am I clear? gov.in. You all got your email IDs. That is called NSE IDs, government IDs. In stands for India. Likewise, .uk stands for UK. These are the particular country. And in that also, you have .org, organization, .com, that is for commercial, .edu for education. So different businesses will have different domain names being allocated by the NCST within India. Likewise, IBM, like Sun, like HP, and so on. Telnet, this is one of the protocol. It's called terminal emulation application. Provides the terminal emulation of remotely connected site. So you can remotely log into that using this telnet command. It uses TCP IP transport protocol with port number 23. Just now we were talking about there are 6,000 odd port numbers in the applications database, wherein each port will have a different application that is being run. For a telnet, it uses 23. For FTP, it uses 20 and port number 21. So likewise, we will see that. Telnet is used for remote logging. It is designed to work between any pair of us. It is only point to point. It cannot be point to multi-point. You can only telnet to the only one host, not to the all. One to one. For example, you see how the telnet works. Host 88.88.88.88 wants to communicate or telnet with host 99.99.99.99. The sequence request goes sequence number 42, acknowledgement 79, with a data called C. Just C is only a data there. On receipt of this data C, along with the acknowledgement and sequence number at the far end, it will revert back saying that sequence number for the 79, acknowledgement is giving 42, it has started sequence number plus 1 is giving acknowledgement as 43. That means 42 yes and 43 is confirming back as an acknowledgement for a data C that he has received it. Then again, this fellow sender will send with other sequence number acknowledging the sequence number 79 plus 1, 80. So this way the handshake takes place and data flows on a Telnet. FTP, File Transfer Protocol. This is a connection-oriented protocol. That's why it uses the TCP. Unlike UDP, UDP is a connectionless protocol. It uses the TCP as a transport protocol for error-free and ensuring the data delivery. Since it is a connection-oriented, it exchanges the messages. That is like handshaking takes place for establishing that connectivity. The port number 20 and 21 are used for FTP as we were talking. Port number 21 is used for establishing and the control messages. For actual data that is being transferred from the sender to the receiver is on port number 20. 21 is for controlling the messages of FTP and port number 20 is used for transferring the data of the TCP. Client and the server, control TCP port number 21, data TCP port number 20. TFFP, it is also a data transfer application, but it connectionless. That means it works on UDP, not on TCP. That's why we were talking that the packet will choose any one of the application will choose any one of the protocol, either the TCP or the UDP. It cannot select both. So TFFP selects the UDP, whereas FTP is through TCP. Being a UDP very lightweight application having a less bytes, less frame, just no discussed. Command. Command is very useful command in our network to ensure that your connectivity between local host to the remote host is existing or connection is live. When you send the ping other IP address, then your request goes there and comes back with some latency. You can understand with the latency how the packet is getting delayed, how much the packet is transiting, how many hops, how many routers in a network. It gives you the latency, the delay. So ping command will talk about, traceroute command also will talk about the latency of this. But ping especially use it to check the network connectivity and its continuity. Sometimes it is also utilizes ICMP, Internet Control Message Protocol. Again, the traceroute is also other utility uses ICMP protocol to find out the path data travels to reach the destination. This I was talking to you. If a packet is getting delayed, that means it is going on a long route. So to ascertain that why the delay, suppose you have a delay of today packet 40 milliseconds, tomorrow delay increases to 80 milliseconds. By giving a traceroute command, you can come to know what route the packet is taking, causing the additional delay of 40 milliseconds. By sitting at your workstation, you can be able to do it. It doesn't require any skill sets for that. It doesn't require any instruments for that to measure it. Simple command of traceroute will talk to you and explain you the reason to address to that problem. Just now we spoke about TTL, time to live. A packet cannot last for long. If the acknowledgement doesn't being received from the receiver, then it will wait for some time and packet get dropped, packet get closed. That's the reason the time to live, how much time the packet has to stay back. So this talks about TTL. This all will be known in a traceroute command when you give on to it. NFS, Network File System, is basically proprietary of Sun Microsystems. It allows system to share directory files with other over a network. Suppose your main office at Delhi and you want to share to Chennai. So your branch office can access to that server using this network to share these files. Again, this is a point-to-point. It cannot be point-to-multi-point. The requester to the server and server response on unicast mode to particular request only. Where we use this NFS, suppose you may be using while configuring your equipment on telecom on your field, that using a craft terminal which don't have the much space or this much space laptops. So you want to use the data. So you remotely use this NFS system. You can fetch the data on your server. You can carry on the process at your remote station. Your remote station doesn't require any hard disk, doesn't require your external hard disk or your floppy drives and all. NFS is used on UDP because this is not that much real time this thing. So you send the request that will come. Most NFS systems are on LAN, high overhead if we use a TCP. So whatever the data you require from your server, it takes a long time. And that's the reason UDP is used for NFS purposes. Currently, NFSs across the WAN depends upon TCP because WAN requires connection. Connection is possible with TCP. Remote login. Just now we spoke about this allows remote login from your terminal to the other host. Web server services, HTTP, Hyper Text Transfer Protocol for browsing to your internet cloud. These are all defined in RFC standards. RFC stands for Request for Comments. It is being given by IETF, Internet Engineering Task Force. Time to time, they keep changing versions. In 1996, they delivered HTTP 1.0, 99 HTTP 1.1. So these keep revising, like your software versions keep changing. HTTP and URLs, we all know uniform resource locators, how to go to the destination hosts to pick up your requisite data on internet cloud. URLs used early by all internet protocols, including various documents retrieval protocols. It works like agent, client and agent. Agent and a server, client and server, that module it works about. You see how a PC running Explorer. Explorer is nothing but your browser. You have a browsers like Explorer, Windows, you have a browser, Chrome, you have a browser, many, Firefox, Mozilla, and so on. So through a browser, PC is running, HTTP request sent, and HTTP request comes from the workstation of the web server. So like this keep navigating. And you have a resource bar, HTTP server, www. Suppose if you want to ask http.www.foo.com.bar.html, the resource for your request is available at .bar. And www.fo.com is the HTTP server of particular end receiver. And you are asking, you are sending your request through URL HTTP. This is way what you do normal browsing on your internet day in day out. HTTP request responses happens many ways. One is on local LAN, other is DMZ, demilitarized zones, and it also works on a proxy servers. It works on local DNS, and it is a transparent on internet to end HTTP server. So client to the server. Again, news. News is one type of service that is being used on the internet. What is NNTP? Network News Transfer Protocol. Protocol is used to send, distribute, retrieve messages. NNTP protocol. It is defined in RFC standards 977. Next is SMTP, Simple Mail Transfer Protocol. This is very, very important for exchanging of your mails. The Simple Mail Transfer Protocol is actually protocol used for transfer of mail from MTA to MTU. MTA stands for Mail Transfer Agent, who is sending the mail. Other is Mail User Agent, who is using the mail. Again, this goes to the POP3 server. We will see what exactly POP3 server and all. The main objective of SMTP is to transfer mail reliably and efficiently. And it is very robust. That's the reason we are using very widely. Operates over TCP port 25. When an application is tagged with the port number 25, it is presumed as this is SMTP. Because network doesn't understand what exactly SMTP. It understands port numbers. To the mail server, it happens SMTP. Again, this is referred in RFC standards. SMTP in client first has to establish a TCP connection between the client and the server. Client then sends the message to the server over TCP connection. It's nothing but other type of a file transfer protocol. Unlike file transfer protocol, file transfer protocol can use UDP also. But this SMTP, it uses only the TCP connection. It does not bother with control. In email POP servers, there's a POP server. When a message arrives the recipient's mailbox, the message has to be transferred to a POP server. The POP server holds the mail message until the recipient retrieves it with his or with own email software. Like what we take a backup on our mail inbox to our local folders. So till then, it resides onto your POP server at the service provider. Suppose you have a Gmail account. In the Gmail server, it will be remaining in the POP server. Your mail, whatever the mail comes to your Gmail account. IMAP 4. It is unlike similar way how POP3 protocol messages from mailbox server over a network. The mail is centrally stored and managed on a mail server and can be backed up by using IMAP4. TCP IP port numbers. After IP passes through incoming data to TCP or UDP at the transport layer, the protocol must perform its duties, then pass the data to intended application process. Just now we saw port numbers. TCP/IP application processes are sometimes called network services and identified by the port numbers. As we told, without port number, network can't understand. The source port number identifies the process that sent over the data, and the destination port identifies the process that received the data accordingly. You've seen physical, data link layer, internet layer, transport layer. FTP 21, which is an application, Telnet application, SMTP application. This way, the transport layer, TCP/IP, flows the packet or sends the packet over the network. There are the standard applications and the default port numbers, FTP 20 and 21. 21 is for control purpose, 20 is for actual file transfer. 22 SSH, secured. 23 Telnet, 25 SMTP, 37 69 TFFP. So there are the different port numbers being used. As I told you, 6,000 plus, only up to 1,000 below are normally being regularly used. Some are used for private purpose. We will see in the next slides. Layer wise, application FTP, TFFP, application layer. These are the applications that is run over TCP. Transport side we use TCP and UDP. Internet we use internet layer. We use IP, ICMP. This is one of our officer was asking what is a layer 3. IP only goes through layer 3. In switch, that is a layer 2, goes only MAC IP. Yeah. Next we will move quickly to the TCP in depth for few more information. Then we will talk about we will talk few more slides on TCP before we go to the network components. What are the components that works onto the network? A TCP, transmission control protocol. It works again on layer 4. Segments, upper layer applications, which we already seen. It establishes end-to-end connection, sends the segments from one end host to the other, optionally ensures the data reliability. Just now we have gone through. We'll see quick additional information. We have seen this. Packet, as I told you, packet uses either TCP or UDP, but not both. Application makes its choice for the user. If you want to use fast for multimedia application and real online gamings, then it is better to adopt for UDP. It's a three-way handshake. It gets asked for synchronization request, it negotiates that and synchronizes and acknowledges that synchronization, and connection is established. This way connection gets established in TCP. And once the connection is established, it starts sending the data. Data is transferred and segments are being sent on the network between the sender and the receiver, between source and the destination. TCP is a connection oriented, as we have just now discussed. It is a three-way handshake. TCP guarantees three things. One is data definitely goes there, and data goes in order, and data goes without duplication. When the data goes in duplication, what happens is again it will be resent. The resent process occupies a lot of the bandwidth throughput on a network, and it takes a lot of delay in that process. TCP does the flow control and congestion control. How, you will ask, how the congestion is controlled? Congestion is controlled by selecting a shortest path. In network, internet is nobody's owner. So nobody owns that network. It is a consortium of the networks. So if any congestion causing in network, it will have a impact on others. So the packet finds the congestion network, it routes the packet an alternate route. So that's the reason we use OSPF, and also we use BGP, Border Gateway Protocol. Somebody else will talk on that next 2 days. Again, as an advantages, TCP has got disadvantages. TCP cannot be used for broadcast or multicast. Broadcast and multicast, UDP is the best suited and DMP is used. TCP has got a lot of features, but it wastes our bandwidth, time and effort, which we are not interested in that. Today, routers, the memory of the routers in a network are very less memories are available, because it uses a lot of memory for processing the request or routing the request. That's why router ports are quite expensive. The TCP is not up to that mark. Where we are deploying the TCP for HTTP, FTP, SMTP and Telnets, TCP is wisely used. Physical layer, network layer, and the TCP works between a layer 4 only, that is above the network layer. And we have a lot of challenges by using the TCPs. What are the challenges? One is addressing challenge, other is the connection establishment challenge, connection release challenge, and how to control the flow of the packets, overflow, underflow, and error detection. In SDH, in TDM, we have error correction codes, we have a HDB3, which is CRC, we have AMI, we have a CMI, a lot of error correction codes, but that is not possible in our data. How, in that case, how are we going to correct the errors? How are we going to recover the data, that is cross recovery? Just now I was talking to you, there are very many applications running on host. When a packet arrives at network, you should know which application it is to send. I was talking to you, there are 65,536 ports, 2 port 16. Ports are onto a machine, that is an applications. As I told you already, one port is linked to one application only, but one application can have many ports. That, for example, FTP has got 2 ports, 20 and 21. How to know what port is what? 021024, that is what we call in 1 kilo in a digital era. 100223, 021023. These are the known ports. And 1024 to 49 are registered ports. There are 49,000 above up to 65 are the private ports. Somebody was asking the TCP header fields. It has got the data, it has got the acknowledgement for the triple handshakes, and it has got a sequence number to ensure the packet will not die. That is, packet will be stipulated in TTL, time to live period only. And it has got a source port, it has got a destination port. Take an example, establishing a connection. Connection establishment becomes tricky when the network loses or network delays, a duplicate packet comes. Take example, while you are doing a banking transactions, what happens? Forget about that. While booking IRCTC ticket, what happens? Even if you go to the payment gateway, if it delays in the payment gateway, what happens? So then how to address that problems? For a delayed packet, a duplicated packet. So for that, you can use a sequence number for which is the packet lost. We have seen earlier packet lost, it will send again retransmit of the packets with the sequence number. If the sequence number is continuing, then it is okay. If the sequence number is broken, that means that packet is delayed. It will wait for that period. If it crosses the TTL, and packet will be retransmitted with other sequence number. The delayed or duplicated packet should die after a while. That's what we were talking that. So IP layer already handles this issue, time to live. For a specific period, the packet between sender to the receiver and vice versa. If the time is crossed, then packet declares this packet is dropped. That is TTL. You cannot keep on transmitting and occupying the bandwidth and delaying the data transfer. That we've seen already how the triple handshake happens, three-way. We have already seen that. Connection release. Connection you are establishing. Then how to release the connections? Host 1 sends the connection request, it acknowledges and sends the data. Second time when it's sending the data, the line got disconnection or terminated. After that, the sender is not able to send the data. Since DR has been sent, that is disconnection request has been sent by the host, no data are delivered from host 1 to the host 2 at this point of. So again, next time it sends only this packet, not this packet again. So this way you can optimize the network bandwidth and release the connections. As I was talking to you, start time to the end time, it will wait for some time to packet to leave. So during this process, the packet will be resent during that period only. Hello? Hello?
Yeah. Tell me, your voice is coming.
I think network is coming or network is what, sir? Network is
yeah, okay.
Network is okay. Yeah. Can you see my present? Can we see my presentation as well?
Yeah. Yes. No problem.
Yeah, fine. Yeah, fine. Thank you. Again, just we talk about the flow control. Flow control is throughput, whether speed that is too fast or too slow. Network congestion, receive side is over. If the network is congested, if the network is slow, the transmission rate adjustment, how it happens. And too slow. If you can see this diagram, transmission rate adjustment, a transmission network here, if your receiver capacity is very small, even if the network is capable of transmitting the more data, you won't be receiving the data what it is desired. So probably the congestion is one of the reasons for this. Not at the network, it is at the receiving party or the receiver end. Too slow, sometimes it may happen the network is congested in between. Though your receiver capacity is more large, but the data is received. In this process, there is a network resources are getting underutilized. How is it before control? Error handling, how you handle the errors. SSH, secure cell hash algorithms, uses port number 22. HTTP uses port 80. Yeah. Then we'll quickly run through UDP, then before going to the network components. quickly run through UDP, user data protocol in depth. Just to be discussed, we'll quickly run through. Unreliable, it works on a best effort basis only. It's a connectionless. No handshaking is required between the sender and the receiver. In this process, we are going to save a time. That's why the delay is less with the UDP packet. UDP will support multiple applications such as the DNS, SNMP, distributed the NFS. UDP is intended only for simple applications. UDP header, we have spoken. Why we should use the UDP? There is no correction. UDP header is only 8 bytes long, 8 into 8. Are you getting all of this? Who cares? You just send it. That means it is not bothered the packet assured delivery. Other applications running on UDP is multimedia streaming. That is simple query like a DNS and all. UDP suffers worse packet loss than the TCP because it don't have flow control check mechanism. It don't have the checksums. When to use the UDP? When you want to have a real-time packet transmissions, it is the only way to use the UDP protocol. Low overhead. It is suits for point-to-point, point-to-multipoint. UDP is the best choice for voice over IP and multimedia applications because it provides very small jitter and wander. The word of jitter and wander is similar to what we use on SDH. The last topic of the today is a network components, what we go through now. Yeah, there are the different network components that works at different layers of TCP OSI reference model and on our internet networking. People used to say network के पीछे क्या है? जो साहब हमको हिंदी में बोलने को बोल रहा था सर, network के पीछे you have lot of this. What are the components in the network? NSE card, modem, the repeater, the hub, the bridge, the router, hybrid devices like a router. The switch, the gateway, network operating system. The NIC card. Just now we have seen the NIC card. This card, every workstation is attached with this card. It is plugged onto your motherboard of your PCB, also called network adapter card. Ethernet and token ring NSEs are connected by transmission medium like a copper or fiber. It can be connected with fast Ethernet, gigabit Ethernet, and so on. Modem, needless to say, repeater. Same way the repeater what we use on our HDH hub, central net joining different networks, a star connection. Use very low-end Ethernets, MPST, How the hub is nothing but a bridge also. It bridges two networks between two workstations. Hub connects all these workstations into one network. A LAN, basically a LAN. This I already shared with the presentation. You have to get the bridge. So some officer has asked what is a bridge. So it is on a LAN with IEEE standard 802.3 connected on Ethernet. Bridge is interface which reads the frame and receives, decides whether to fit it forward frame based or not. It doesn't know that address is elsewhere, only knows it is there, and so it sends. Connect homogeneous networks. Break up single LAN into smaller LANs. I don't know how many people you might have seen earlier cyber cafes have come. When the cyber cafe, he takes only one internet connection and that he terminates on one hub or bridge, and he will distribute among so many workstations. So that's why that he uses these components. Router. Answer our question between the layer 3, layer 3 switch some officer has asked. Router is a device that interconnects subnetworks which may differ in lower 3 OSI layers. That means it is works purely onto the IP. Decides whether to forward the packet by looking the protocol level. The protocol level, either TCP or UDP, rather than MAC address between two networks. It looks only a protocol level. Protocol level TCP IP. IP is only the address. It never looks for MAC. Probably this will answer your question as well. It identifies the network addresses, all possible paths between, and transmit a message to the destination through routing, routable protocols through a routing tables. It addresses the issue of addressing, routing, segmentation, reassembling, packet, depacketizing. Router. You have a WAN, you have a different servers, different work groups. It will be. In hybrid devices, which we are talking about, the router, bridge cum router, operates at OSI data link layer and network layers. Because it has got a bridge, it has got a router. This is hybrid device which works. Route using one or more specific protocols, the example IP, bridges all internet traffic maintaining protocol transparency. Router, again router, similar server plus router. Router likes like a concentrators. Switch. Yeah, you've seen that switch operates in data link layer 2 and MAC address. It never operates again. There are different type of switches: manageable switches, unmanageable switches. Manageable switches, you can define each port bandwidth also. You can zip the bandwidth. Usually switches operate at L2 data layer of OSI reference model, while router operates at layer 3 network layer. Routing switches, however, perform L3 functions usually reserved for. So these are L3 switches. A special switches works on layer 3 for IP. Gateways operates at all layers of heterogeneous networks, different WANs, different LANs through NOS. So this is the total inter-networking. WAN you have one side of the Ethernet, other side is the token ring, other is fiber data distribution. That's all for today from me. Tomorrow we will be talking, before taking some questions, tomorrow we will be talking about IP addressing. What is IPv4? What is IPv6? What is the challenge we have with IPs? How to address the challenges using a NAT, network address translation, and port address translations. And we'll talk about LAN, WAN, VLAN, and SD-WAN, which is the latest technology. And we talk about, I will just touch upon 2 slides on MPLS just to start with, along with the VPN. And I will be talking more onto it, where we deploy MPLS VPN in the industry. And we will be talking, I have been asked to talk about the commercials, the charges between normal internet bandwidth and the MPLS charges, port charges. I'll be touching upon that tomorrow. So over to you, please. Any questions, sir? We can take the questions for next